Prakash, working as an assistant professor in the Department of Mechanical Engineering, SNS College of Technology. Today we are going to discuss a topic on actual Rankine cycle in the subject Engineering Thermodynamics. So, coming to the topic, we have discussed about already the ideal cycle and actual cycle. So, if you take the ideal cycle, here it is the all process ideal in case of ideal cycle, whereas in the Rankine cycle, the actual cycle, what happens is definitely there will be a difference in the ideal cycle and the actual cycle. So in the actual cycle, what happens is there is a chance of frictional loss and leakages. So this plays a very important role comparing the Rankines and the actual and the ideal cycles. Because of this, what happens is the efficiency is increased in case of ideal cycles. But if you compare to the actual Rankine cycle, the same efficiency cannot be expected because the efficiency is lost because of this leakage and the frictions. Now coming to the cycle. So this is the schematic diagram of the actual Rankine cycle. See, let us discuss what are the components in this Rankine cycle. So if we take here, so this is the layout. So let us see what are the components available here. First one is a boiler, okay, and then there is a turbine, and then here there is a condenser, and here there is a pump, there is a hot well, and there is a feed pump. Now let us discuss what are the main components and their functions. So initially there is a boiler. So what is the purpose of boiler is, when the water is supplied to the boiler, so it is getting heated. So this water is converted into superheated steam. So this steam comes to the turbine. So where in the turbine the heat energy of the steam is converted into mechanical energy. So when the turbine here, the heat energy of the steam, expansion process takes place. So because of this work done, the work output is received in the turbine output. So after that, the steam coming outside may be a wet steam or a dry steam. So this steam comes to the condenser. So in the condenser, the heat is rejected outside. So the steam again is converted into water. So this water comes here by using the pump. It is going to the hot well. So here the water is stored here. The same water is again it is sent to the feed pump. So this is pumped to the boiler. So this is the actual Rankine cycle. So here, what are the four processes taking place is in 1 to 2. Here 1 to 2. So water is going where heat is added in the boiler. And coming to the 2 to 3, here expansion process takes place. That is isentropic expansion takes place. So here and then 3 to 4, heat is rejected outside. So heat is rejected outside, and here from 4 to 1, again here water is pumped through the pump. So here compression process takes place. So these are the four stages. Comparing the cycle, see here. So this is the curve where the area, again this is the liquid, and here it is the wet steam, and here it is the superheated steam. Here this is the critical point where it is starting here. This is water. So when the water is pumped in the pump, what happens is the pressure increases. Okay, it attains the stage 2. Okay. Then what happens is when heat is added, the temperature increases and water is converted into wet steam initially. So when it reaches here, it is dry steam. Again it is continuously heated, so it reaches the superheated steam. And then from 3, what happens is here it goes to the turbine where expansion process takes place. So that what happens is the heat is lost. The heat lost is converted into work. So what happens again, the superheated steam, when it is losing the heat, it goes to a dry steam and initially it becomes wet steam. Okay. Then in the condenser, what happens is heat is rejected outside, so that the wet steam is converted into water. So again the water is pumped to the boiler, heat is added, it is converted into superheated steam. Again it is converted, heat is lifted and water, the same process continuously done. Okay. So here this line, how much it can be increased, so that much of thermal efficiency can be expected. Okay. So this is our working of an Rankine cycles. So we are coming to the real time application. This Rankine cycle is used in the thermal power plants. Now as a students, I am going to give a small discussion here. So how to improve the actual Rankine cycle? Let us have a case study. Okay. How to improve the Rankine cycle? That is case study on improvement of Rankine cycles. So this can be approached by the design thinking process. What is the first stage in the design thinking process? Empathy. Finding. Now I am giving a problem statement to you. What is the problem statement is? So this is the process. With the help of this process, I want to improve my thermal efficiency by identifying the wastages or any things in this real-time application. This is my empathy. I am telling the empathy part. Okay. I want to improve my efficiency of this cycle with the happenings here. Okay. You as a students, okay, you can think yourself, okay, and then what you can suggest me how to increase this. Can you understand what I am saying? Yes. Okay. One small example I take a real time. You can go for an on the roadsides when you are going there. You can see sugarcane juice making. Have you seen that machine?
Yes, sir.
First, what they do? Initially, they put the sugarcane, okay, inside this. So when it crushes, some amount of juice is there. He's throwing that other immediately. No. Why? Reuse. Again he is reusing. So extracting some amount of juice. And then the two wheels are rotating. The distance between the two wheels is reduced. Again the pulp is made to go into the two wheels. So continuously is repeating the process till the final tip of the juice is extracted. Okay. So this is how the extraction process takes place. By thinking this, now you can suggest how to improve the efficiency of the Rankine cycle. Can you come? Anyone? Where should you use Come. What's your name?
In a study, how to increase thermal efficiency, we can use waste steam and again reheat to rotate the low pressure turbine.
Oh, you are telling that we can use the
Waste steam or
waste heat to reuse it.
reheat and rotate the low pressure turbine.
Okay, very good. What Pradip has told is, so the steam coming out can be reused to increase the by using a low pressure turbine, and then we can make it. Okay, very good. Any others? Your ideas?
Hello everyone, I am Pradip Shankar. Steam is come out from the turbine. It contains some hot heat energy. So we reheat them and pump it into the boiler. So we can reduce the fuel cost. And this is one of the way to.
So what you are telling is, you are using the heat to increase the temperature of the water. Can you understand what he is saying? So what is Pradeep's idea is, the heat which is coming outside can be used to heat the water here, and then that water can be sent to the boiler. So that what happens is, initially heated, so that the usage of coal is reduced, and then this combustion takes place quickly. So this is one of the methods to improve the efficiency. Very good. Any others?
In
in this Rankine cycle process, the boiler will be heated with some fuels, so that the flue gases will be passed through this. There will be a air moisture content, so that the air moisture content will make a lower temperature, so that we can make a preheated air moisture, so we can make a low fuel.
So can you understand what he is telling? So what his point of view is, so in the boiler you are using the fuel to burn. After burning, the fluid gases goes outside with a lot amount of heat energy. So here for combustion process we need air and water. So air normally contains moisture content in it. The fluid gas which is going waste outside, it contains some amount of heat energy. So that heat energy can be used to heat the this air. Okay, so burning takes place quickly and combustion takes place. Very good. Any others? Any other idea? So this is we have discussed the Rankine cycle and the case study how to improve the efficiency of the Rankine cycle. Thank you.